All right, here is your homework over target 4. So as a reminder, we are solving exponential equations. So if you notice, all of these problems have a variable in the exponent. And target 4 is divided into 2 parts. So the first part is method 1, which we call equating the exponents. Another way to think about this is you have to find the same base. So that's going to be my goal to start off with on numbers 1 through 6, is finding the same base. So 6 can actually just stay as 6 to the first power. That's still to the 1 minus r. But 36 can be written as 6 squared. So then what we're going to do is take our exponents and set them equal. So when we multiply 1 times 1, or 1 by negative r, it stays as 1 minus r equals to the exponent over here on the right, which is 2. And then when we solve, we'll subtract 1, so we get negative r equals 1. So ultimately that means r equals negative 1. Remember, on all these problems, you can plug it back in to check your work. All right, on number 2, we have 6, 25, and 25. So we're going to find the same base. So the first thing I'm thinking is 25 squared is 625. So we can write that as 25 squared. And the nice thing about that is then we can just leave this as 25 to the first power. We don't even have to worry about changing the base over there. So I'm going to multiply these exponents together. So that would be 4p plus 6. So remember, once you have the same base, then you just ignore the bases and you set the exponents equal to each other. So I'm going to subtract 6. So 4p equals negative 5. And then if I divide by 4, I would get negative 5/4. So our goal here is to find the same base and then set the exponents equal. All right, over here we're going to have to do a little bit more work on number 3 because 4 and 32 are both going to have to be changed. So 4 is 2 squared, still to the 3n. 32 is 2 to the 5th power, still to the n plus 2. So in this next step, I'm going to actually ignore the bases and just multiply the exponents together. So 2 times 3 is 6n. And then distributing the 5 over here, that's 5n plus 10. And then if I subtract 5n from both sides, I get n equals 10. On number 4, these are pretty big numbers. I'm actually going to think about 27 first. I know that 27 is 3 to the 3rd power, so I'm wondering if I can write 243 to the 3rd power, and I can. It's 3 to the 5th power. So I'm going to write 243 is 3 to the 5th power, still to the 3n. This is to the, oh wait, hold on, let me just rewrite that. I know my handwriting's bad on these. I'm doing the best I can. All right, so this is 3 to the 5th power to the 3n. And this is 3 to the 3rd power. Okay, so when I multiply 5 times 3n, that's 15n equals 3. And if I divide by 15, and I'm going to simplify this, I get n equals 1/5. All right, and then that's actually really nice because on number 5, it's the same 2 numbers. It's 27 and 243, so I don't have to do much effort here. 27, remember we just did this, is 3 to the 3rd power. So to the negative 2x. 243 is 3 to the 5th power. Keep the exponent on the outside. And now we're going to multiply the exponent. So this is negative 6x, and this is 15x minus 5. And so I'm going to subtract 15x. So that's negative 21x equals negative 5. And if I divide both sides by negative 21, I get x equals 5/21. And then I actually didn't, do we have these numbers before? No, we didn't. So 36 and 216. So when I think 36, I think 6 squared. And then testing in my calculator, 6 to the third power is 216, so I can use base 6. So 36 is 6 squared, still to the 3n. 216 is 6 to the third power, still to the n minus 2, and then multiplying the exponent, so it's a 2 times 3, which is 6n. Here are the exponents. If I distribute the 3, would be 3n minus 6. So I'm going to subtract 3n. And we get 3n equals 6. So if I divide by 3 on both sides, I get n equals 2. So that's all the first method, which is equating the exponents. I also like to call it same base, because in that first step, you're rewriting the problem and making it so that both sides have the same base. So here on the second part of target 4, we are not able to use same bases just because the numbers don't work out that way. So we use logarithms. So the first thing you're going to do is whatever's being raised to the exponent, you're going to get it by itself. On 7 and 8, that's already happening for us. So we can go straight into putting this in logarithmic form by looping and scooping. So log base 4 of 23 equals k. And then to put that in my calculator, remember we use change of base formula. See the notes. If you didn't watch the notes, make sure you do that first so you understand what I'm talking about here. Equals k. And then I'm going to put that into my calculator. So the log of 23 divided by the log of 4. And then I'm going to round that to 3 places. So k equals 2.262. And you can plug that back in to check your work. Since we are rounding our answer, just make a note that it's not going to come out to be exact, but it'll come really close when you plug it back in. So same idea here, loop and scoop. So that would be log base 18 of 7 equals k. So to put that in your calculator, you would have to do log of 7 divided by log of 18. It's always the last number over the first number. So throwing that into my calculator, log of 7 divided by log of 18, which is going to be 0.673. All right. So here on starting with number 9, the first thing that we're going to have to do is get rid of anything that's not being raised to the exponent. So in this case, we're going to have to subtract 3. So we have 11 to the x plus 9 equals, that would now be 66. And now we can do what we started with in the last 2 problems, which is loop and scoop. So this would be log base 11 of 66 equals x plus 9. I'm going to take this up here. So that means I have to do log of 66 over log of 11. So log of 66 divided by log of 11. And that number is 1.747. And remember that still equals, hold on. That still equals x plus 9. So now we're going to have to subtract 9 from both sides. So we get negative 7.253 equals x. So make sure to watch that back because there were some steps there that I couldn't write. I just didn't have enough room. So if you need to go back and watch that, make sure you do that. So on number 10, the only difference between number 9 and 10 is here on number 10, the first thing we're going to do is get rid of that negative 8 by dividing by negative 8. So that gives us 16 to the p minus 9 equals, and I'm going to go ahead and simplify that just so it's easier in the next step, which is 3.5. And then I'm going to loop and scoop. So log of 16 of 3.5 equals p minus 9. So now I'm going to type this into my calculator. So I'm going to do log of the last number, so log of 3.5, divided by the first number, so log of 16. And make sure when you do that, you get 0.452. And remember, that's still equal to p minus 9, so we have to add 9 to both sides. So our final answer here is going to be 9.452. All right. And now we have 11 and 12, which just have a little bit more going on there. There's just a lot up front. So the first thing we're going to have to do is get this 19 to the exponent by itself. So to do that, I'm going to start by subtracting 1. So now I have 1.1 times 19 to the negative 7x minus 2.5 equals 26. Now I have to get rid of that 1.1, so I'm going to divide by 1.1. So now I have 19 to the negative 7x minus 2.5 equals, and I'm going to call it 23.636. And now that we have whatever's being raised to the exponent by itself, now we can loop and scoop. So it just takes a while to get to this step, but that's what we're ultimately looking for. So we have log base 19 of 23.636 equals negative 7x minus 2.5. So to put this in my calculator, I would have to do log of 23.636 divided by log of 19. And remember, that's still equal to negative 7x minus 2.5, negative 7x. So I'm going to throw that into my calculator. So log of 23.636 divided by log of 19, and that number is 1.074 equals negative 7x minus 2.5. So my next solving step would be to add 2.5. So now I have 3.574 equals negative 7x. And so now I'm going to divide by negative 7 to get that x finally by itself, which is negative 0.511. So like I said earlier, these problems you might want to go back through and watch a couple times. Just because there is a lot going on, and a lot of it is just basic solving, but there are a few steps up front that are new to you, and logarithms are just kind of an uncomfortable topic because they are brand new. There's not a lot that you guys look at this year that is this new. So the nice thing about 12 is it's very similar to 11. So the 15 is being raised to the exponent, so we've got to get rid of the 4 and the negative 8. I'm going to start by subtracting 4. Now we have negative 8 times 15 to the 5 minus 7p equals negative 2.2. So then I'm going to divide by that negative 8 out in front. So now I have 15 to the 5 minus 7p, and that number when I divided it was 0.275. So finally I have whatever's being raised to the exponent by itself, so now I can loop and scoop. So I have log base 15 of 0.275 equals 5 minus 7p. So to plug this into my calculator, I have to do log of the last number, so log of 0.275 divided by the first number, log of 15. And that still equals 5 minus 7p. Yeah, there we go. Well, that's not what I wanted. Let's try that again. Minus 7p. There we go. So throwing that into my calculator, divided by log of 15. So that number is a negative 0.477 equals 5 minus 7p. So my solving skills tell me to subtract 5 first. Moving out a little bit of a delay here. So I subtract 5, so that's negative 5.477 equals negative 7p, and then divide by negative 7. So the final answer would be 0.782 equals p. So that's your homework. Again, you might want to watch the notes. If you skip the notes, make sure you go back and watch those, I would say first, but a little bit late for that now, just because I did talk more about like some things that you throw into your calculator. So here I'm assuming that you already understand that. Make sure you go back and watch both videos this week. Have a great one.